All right, now we're really focusing in on estimating square roots. So if I'm looking at the square root of 13 and I want to round it to 1 decimal place, you already know that it is more than 3.5, right? But it should be pretty close to 3.5 because 3.5 squared was equal to 12.25, right? So we know it's going to be pretty close to 13. So what we're going to try now is 3 decimal 6, and we're going to multiply, or we're going to square that. And so that equals 12 decimal 96 hundredths. I'm going to try to get even closer. So let's see. Do you think 3 decimal 7 squared is going to be closer to 13 than 3 decimal 6 squared? Probably 3.6, because you can't get much closer to 13 than 12.96. As well, look how much bigger 3.6 squared is than 3.5 squared, right? So I'm assuming that this one is going to be further away from 13. I want you to just check on your calculator, making sure you can use it. So 3.7, and you can either hit the squared button, which looks like this, or you can just multiply it by itself, and that would be 13 and 69 hundredths. It is closer, right? And now if I was going to estimate approximately 3 decimal 6, and then I'm just going to go to 1 decimal place here. Now when we use our calculator to estimate a square root to 1 decimal place, we're going to use like guessing, checking, and revising. Then check your estimate using a calculator. Okay, so I know the square root of 4 is 2, and I know the square root of 1 is 1, right? Okay, so I know we're going to be in here somewhere, and the square root, so as I figure this out, I would see which it's closer to. I'm going to use 1.5, and I'm going to square that. So that would be 2.25. So that is too big, right? So then I can just keep moving down. So I'm guessing and then I'm checking, right? So 1.4 times 1.4 is going to be 1 decimal 96. So I know that the square root of 2 is approximately 1 decimal 4. And it's going to be somewhere right in there, real close. Okay? 70. If I'm thinking, what is the closest perfect square? So 8 times 8 is 64, right? There's 8. I know we're going to land somewhere in between 8 and 9, because 70 is bigger than the square root of 64. So I'm looking at this, and again, I'm going to try that middle number. So 8 decimal 5, and I'm going to square it, and that is going to be 72.25. So a little too big, right? So I'm going to try 8 decimal 4 squared. So the guessing and the checking again, and that is going to be 70 decimal 56. And then I'm thinking, because there's such a big gap in between there, that this one is going to be the closest, but we'll just have a check and see, because I could be wrong. 68 decimal 89 hundredths. And so it is approximately 8 decimal 4. Use fractions now to help us estimate, connecting everything all together. Looking at this square here, right? How many squares are shaded in the last layers? Layer 1, layer 2, layer 3, layer 4. Okay, so how many are shaded in the last layer? There's 2. Right? So if there's 2 in the last layer, how many in total, how many boxes in total are there in this last layer? So I'm hoping that you said there's 7. So if I was going to write this as a fraction, what would that be, right? It would be 2 over 7. So there's 2 out of a total of 7 squares that are shaded, right? All right, so notice that in the second square, almost every square in the last layer has the same amount shaded. So this part here, right? If we're looking at the little tiny bit on the outside here that's shaded, it's almost all exactly the same, okay? Now, there is one part right here that is not, but we're going to pretend that it is because we're estimating, okay? We pretend that all squares in the last layer have the same amount shaded. So what will, knowing how much of each square in the last layer is shaded, tell us? What it's going to tell us is the side length of the square. This is 3 from here to here, and what it's telling us, this little part here, is how much bigger it is than 3. Now, if we estimate how much each square in the last layer is shaded, then we can find an estimate for this part here to this part here is the square root of 11, right? That's the length of that side. So I'm gonna get rid of that, little 3 there. From here until here, this whole area there is the square root of 11. Okay, remember that is a number, so we can say that that's the length of that side. Okay, so if I said the squares in this example and this example have 11 square units that are shaded, okay, so these are the equal amounts. The first 3 layers are shaded completely, and only 2/7 of the 4th layer is shaded. So 2/7 of the 4th layer is shaded, but yet these 3 layers are shaded in total. Almost all squares in the 4th layer is shaded, right? So each square has approximately 2/7 of it shaded. 11, the square root of 11 is approximately 3 2/7. If we want to calculate that, I'm going to get you to get your calculators out again. How do we calculate this? So this in here is like another division sign. So I'm going to write this out, okay? So it would be 3 plus 2 divided by 7. So on your calculator, if you take this square root of 11, it's 3 decimal, and it's like goes on forever. It's 3 1 6 6 2 4 7 9 0 3 5 5 4. Okay, now if I do this equation, what part do I do first? I want you to think about that. I do the division first, right? If we're doing orders of operation, multiplication and division is first. I do 2 divided by 7, then adding 3. I have 3 decimal. 2 8 5 7 1 4 2 9. Now I'm going to round this number because this is a ridiculous number to try to use. So we're going to round each number to the nearest whole number. This one is if we look here, is the 2 greater or less than 5? It's greater than 5. So this would round to 3. We look here. 3 is less than 5, so this would round to 3. So they both round to the same whole number. So the 11 square root is approximately 3. Or if we want to do it to the nearest decimal, I could say it is 3.3, and I can double check that by looking here, and 8 is bigger than 5, so that would be bounced to a 3 there, and 1 is less than 5, so that would be a 3. If we were going to round the next number, would it be the same? It would not, right? Because this would become 3.29, and this one up here would be 3.32. If I'm looking at this number line, if I'm estimating, and I'm wanting to make sure, like, it's very important that we understand where things fit on the number line. So the square root of 10 is going to be closer to 3. The square root of 11 we know is about 3, but it's about, if we go to 1 decimal place, it's about 3.3, right? And then I can actually take the square root of 10, and if I estimate it, so it's actually 3.1622, but I'm only going to round it to 1 decimal place. So it would be 3.2, right? And then I can prove that all of these fit on the right on those spots.